In this lesson, you'll be introduced to proofs. We're starting with an example of a two-column proof. And we'd like you to check out the proof that's listed. Put the video on pause, take 1 minute and respond to these questions. What do you notice? What do you wonder about? Now we're going to review some properties of real numbers. And in truth, you've been learning about operations with real numbers since early grades. Some of what you already know will be useful as we write two-column proofs. So to review the properties of real numbers, we'll have a two-column chart here, which is property and example, and we'll start with the commutative property of addition. And that one can be represented this way: a plus b equals b plus a. In other words, it does not matter the order in which you add two numbers together. Commutative property of multiplication: a times b equals b times a. And the associative property of addition, remember this one has to do with grouping symbols or parentheses. It does not matter if you have three numbers or more and you're adding those three numbers. It does not matter which two numbers you group and add first. It's going to be the same result. So a plus the quantity b plus c is equal to the quantity a plus b plus c. Now the distributive property is definitely going to be familiar. It looks like this. It says a times the quantity b plus c is equal to a times b plus a times c. And that distributive property also works when there's a minus sign between the two terms in the parentheses. The substitution property may not be as familiar, but hopefully it will make sense. If we know that a is equal to b, then b can be substituted in place of a in any equation or expression. So those are some properties of real numbers. Now let's look at properties of equality. The addition property of equality. It says if you start off with an equation like a equals b, then a plus c is equal to b plus c. Notice what happened. We are just adding the same number to both sides of an equation, and the equality holds true. Subtraction property of equality is very similar. If a equals b, then a minus c is equal to b minus c. How about the multiplication property of equality? Starts out the same way. If a equals b, then a times c is equal to b times c. In other words, I can multiply an equation by the same number on both sides and the equality still holds true. Now, division property of equality is good with one exception. And let's show you that one. If a is equal to b, and here's your exception, c cannot equal 0, then a divided by c will equal b divided by c. Reason is that you cannot divide by 0. That is an undefined expression. So that's our one stipulation for the division property of equality. Now the reflexive property of equality may be unfamiliar to you. It's quite simple. For any real number a is equal to a. In other words, any number is equal to itself. The symmetric property of equality basically says you can read an equation from left to right or right to left. If a equals b, then b is equal to a. Transitive property of equality. This one is interesting. It says if a is equal to b, so that part is given, and b is equal to c, that part is given, then we can conclude a is equal to c. So what we're going to do is we're going to apply these properties of numbers and properties of equality by solving an equation. And we're not only going to solve the equation and show what the solution is, but we're going to show each step of our reasoning and justify each step. So we're going to start with this two-column proof. The statement is on the left, the reason is on the right, and we are solving the equation that is 4x plus 3 is equal to x plus 5 minus 2x. Now the reason is that one is given. So most often the given statement will be at the top of a two-column proof. Now on the left-hand side, there are some terms on the right side of that equation that we can combine. 1x minus 2x is equal to negative 1x, right? So we can rewrite the equation as 4x plus 3 is equal to 5 minus x. And the reason is that we have just simplified or combined our like terms. Now, whenever we have an equation and there's an x on both sides, we want to get the x's together. So that minus x that's on the right, if I offset that with plus x, and I do the same thing on the other side of the equal sign, that's going to be our next step. So I'm adding x to both sides by the addition property of equality. So 4x plus 3 plus x is equal to 5 minus x plus x, addition property of equality. Now let's simplify the equation on both sides. We end up with 5x plus 3 is equal to 5. We've simplified. Now remember, the goal when you're solving an equation is to get the variable by itself, and we use inverse operations to do that. So to undo add 3, we're going to subtract 3. But we must do that to both sides of the equation. So 5x plus 3 minus 3 is equal to 5 minus 3. That's the subtraction property of equality. Now let's simplify both sides of the equation. 5x is equal to 2. The reason? Simplify or combine like terms. And our last step to get x by itself is to undo what's happening to the variable. 5 is being multiplied by x, so we are going to divide both sides of this equation by 5, giving us our final solution of x is equal to 2 divided by 5, or 2/5. And we applied the division property of equality.